Okay, section 3.6. I had you do the definition of derivative in the last section, and it almost seems mean, but I'm going to show you a really easy shortcut in finding derivatives. But showing you the definition of derivative was important. It helps give you a better understanding of what a derivative is, and also it'll give you appreciation for the shortcut as well. So first of all, we have what's called a constant rule, and maybe I think I assigned you a problem where the derivative, we're trying to take the derivative of a constant and you got it to cancel out, or maybe that's something that you noticed that every time you took a derivative of some of the constant, it ended up canceling out and it was never there. Well, in fact, the derivative of any constant that you take, any derivative of any constant, so it doesn't have a variable along with it, is just 0. So this guy's derivative, and we call the derivative f prime of x. I think we talked about that. And that the derivative of that equals 0. So if we're taking the derivative of a function with just a constant, or just a constant itself, that guy's derivative is automatically 0. The power rule now. The power rule says that if we're taking the derivative of a function, and it's that x is raised to a power, where n is a rational number, then all we do is we do this rule here, and all this is saying is this is n. All right? All this is saying is that we bring n down, so we bring n down, and we decrease its power by 1. That's all it's saying. All right, this definition makes it look more complicated than it is, but if you just think about it for a second, it's really not complicated at all. So we can go ahead and let's say they say find the derivative of each function. So on 1, we're going to use the power rule. We're going to use the power rule, and we're going to take the power, which is 2, we're going to bring it down. So that now becomes 2x, and then we're going to decrease the power by 1. So 2x, the first power, which is just 2x. 2 is the same thing. All right, we got negative third power. So we're going to bring the negative 3 down. So a negative 3x, and we're going to decrease the power by 1. So a negative 3 minus 1 is a negative 4. So now that guy's derivative is negative 3x to the 1/4 power. And like you learned in algebra, you know that with this negative power here, that all that means is it brings this x down to the denominator. So this guy's actual answer here, we can write him as negative 3 all over x to the 4th. So we now have a positive exponent. All right. So knowing that number 3 should be fairly easy, all we have to do is we have to rewrite number 3. Let's bring number 3. Let's bring that x up to the numerator. And to bring that x up to the numerator, all we have to do is we have to write it as x to the negative 1. Well, then we can use our power rule. All we have to do is bring the power down and subtract the power by 1. So when I bring that power down, I'm going to get a negative 1x out in front, and subtract the power by 1. Negative 1 minus 1 is a negative 2. And to rewrite it in fraction form, again, we leave our constant alone. Leave our number out in front alone. All right. So we leave a negative 1 out front, and we just switch the x to the negative 2. We switch that down to the bottom. So x squared. All right. Hopefully remember that from algebra. If I have like 1 all over x to the negative 2 power, to rewrite that, so we don't have a negative exponent, all we need to do is to move that to the top, because this negative exponent means just flip it. It either goes from the top to the bottom, like in this case over here, or it goes from the bottom to the top if it's a negative. All right. So then we have what's called the constant multiple of a power rule. Just the only difference between this rule and the power rule is saying that, okay, now we have a constant in front of our function. So now all we have to do is when we go down, we have to multiply. When we bring this power down, we have to multiply n times the constant. So when we're going to multiply the power times the constant in front of it. Okay. So all we do is we bring this power down, we bring this 3 down, and we multiply it by the constant out in front. The reason why that power rule wasn't really defined there is because these constants and all these were always 1, weren't they? So obviously 2 times 1 is 2, so that's what we say. So these rules really aren't too different. So I'm going to bring that 3 down, so I'm going to multiply 3 times 2, and I get 6. And then I'm going to decrease my power by 1. So 6x to the second power, 6x squared. All right, same thing. Anytime we're going to have 1 in the denominator, we're going to bring it up to the top. And to bring that guy up to the top, we're going to write it as x to the negative 4. So I have 3x to the negative 4 power. And to take this guy's derivative, all we do is we take the power, we bring it down, and we multiply it. So I'm going to have a negative 12x, and then we decrease this power by 1. That's negative 5. And that's it right there for example 3. The sum rule is saying if we have one term plus another term, so say we have like an x squared plus x, obviously we can't add those because they're not like terms. When we take the derivative of a function like this, we're going to take the derivative of each of these separately. All right, and we can just keep our plus sign or our minus sign where it is. All right. So it says find the derivative of each function. I just give you one function here. And all it means is that we're just going to take each of these separately. So in this one, we know we bring the 3 to take this guy's derivative. We bring the 3 down and multiply it by 6. So we get 18x. Decrease the power by 1. So 18x squared. Minus then, again, bring this power down, multiply it by its constant. So 8x. Subtract this power by 1. All right, and that's just 8x. Again, bring this power down, which is just a 1. When it's not written, it's just a 1, so 1 times 2 is 2. 1 minus 1 then is x to the 0 power. Anything to the 0 power is 1, so we're just left over with 2. And then we know the derivative of a constant is 0. So our derivative, our f prime of x, equals 18x squared minus 8x plus 2. The last problem I have for you, and we did some of this in the last section, we said find the equation of the tangent of the line tangent to the graph at this point, and write the equation of tangent line in slope-intercept form. We did some of that in that other section, and we knew that we had to take the derivative, but we had to do the long way of taking the derivative. Now what's nice is we're going to take the derivative to find the slope. So our first step is take derivative, and then the second step is plug in your x value to find your slope. And the last thing to do then is use point slope to write the equation of your line, and then you're going to have to simplify to get it into slope-intercept form. So first step number 1 is take the derivative. So we need to find this guy's derivative, and the reason we take the derivative is because it gives us the slope of this function at any x value in this entire graph. So we're going to take this guy's derivative. Again, we got to bring this 4 down, subtract the power by 1, so 4x cubed. Minus, bring the 3 down. 3 times 2 is 6. Subtract the power by 1. Bring my 2 down. 2 times 5 is 10. Subtract the power by 1. And we know that the derivative of a constant is 0. They want us to write the equation of the tangent line at this point, negative 2, 44. So we said to plug in the x value to find the slope. So we want to know what the slope of our equation is at negative 2. So let's go ahead and let's plug negative 2 in anywhere sitting x in the derivative. So we're going to get 4 negative 2 cubed minus 6 times negative 2 squared plus 10 times negative 2. All right, so negative 2 cubed is a negative 8 times 4 is a negative 32. Negative 2 squared is a positive 4 times 6 is minus 24. And then 2 times a negative 2 is negative 20. It looks like we're going to have a big negative slope. So we're going to have, let's see, what's this? Negative 44, negative 76 as the slope. All right, I don't think I missed a negative sign in there. Nope. So that's a really, really big slope. All right, so they said the third slope was then to put in point slope form. So we're going to say its point slope form is y minus our y value, 44, equals our slope, negative 76, times x minus our x value, so it's x minus a negative 2, which becomes x plus 2. Distribute my negative 76, so I'm going to have y minus 44 equals negative 76x minus 76 times 2, which would be 152, I believe. All right. And then we're going to then add our 44 and add 44. in order to get y by itself. So y then equals a negative 76x minus 108, I believe. So that there is your equation of the tangent line at the point negative 2, 44. I hope this helps, and I hope you're happy now that you know the shortcut for derivatives, and we'll see you in class.